Hello, what's up, everybody? This is Papa Bale, and welcome to the channel. Uh, so I'm salvaging and getting ready all the components I'm going to need to build my next uh, piece of art, the next work. So as soon as I stop this, I'm going to break it down. There are 3 bifilar coils lined up on one side, and then there's 3 trifilar coils lined up on the other side. And then there's 2 single file coils at the sides. So, and it's an 8 magnet rotor, 8 coil electromagnetic rotor. And I was just testing out the balance currently. I mean, it's all going to change. I was thinking about maybe putting this on there, but it looks like it's going to be a little bit too big, so I might have to put a smaller one on there. It's a bridge rectifier. The gauges are 26, 28, and 32. So it's going to be really cheap to run. We're going to put 3 batteries up on the top here. And yes, I will print like a crown for it. Oh, wow. It'll be awesome. I'm charging up all the batteries that I'm going to be using. Let me think here. I'm waiting for like little breadboards like this to come in the mail. I have 2 of my halogen bulbs. I need 3. I have all the transistors I'm going to need. Got all the batteries. I got tons of jumper wires that are going to come in. They're 22 gauge jumper wires. Yeah, I got this is a counter rotator, or it's gonna be. I might see. I'm gonna print another outer rotor, and we are gonna try and make it more balanced. Because I think if we can lower this on the pole and build a new one of these that's even, I think that's pretty balanced. The inner rotor. You know, just let it be down a little bit lower on the pole so it's not so high in the tree. You know what I'm saying? So what the 3 and the 3, the 3 bifilers and the 3 trifilar coils are 180 from each other. So they're going to be, all that 26 is going to be in a drive, 180 style. That's why we only need 3 transistors. Now you could build it with 6, but I don't think we have room for that. Like, honestly. But we'll see. I don't know, man. We might have the components for it. We might go straight parallel with this. We're going to have to split the energy, 1 battery for 2 circuits. You know, like we'd have to do some crazy stuff. But I think the 180 and having just 3 is the way to go. And this outer stator rotor stator, It only has 6 slots for magnets, so I'm gonna build like another, like a little smaller, but it'll have 8. It'll be able to match up with the inner rotor. That should be pretty awesome. Hello, hello. How's everybody doing?
Double tap.
Double tap.
Be a like. Double tap the like button, or double tap and it likes it.
Like, yeah. Yeah, I think this is gonna be great, just based on what I see now. Yeah, it's gonna be smooth. I mean, just the having all the coils on the end here is adding like a lot of like torquish energy to this. I mean, it takes a while for me to stop it. I have to really put some energy into stopping this. Granted, it is a pulse motor, so I'm gonna take this lamp right here. I'm gonna shove it back in this other one because I'm not gonna be able to build that one right now. I wish I could. All right. The one that I'm working with over here is a triple ringer. It's got 3 rings to it instead of just 2. Everything's magleved all the way down. It's awesome. All right, now some people may have wanted to see how this one gets built. It's in layers. It's in 3 different layers, well 4 layers actually. Got the outer first. And you got the coils in the middle. Most people think this is where it stops because you can't see the one in the middle or in the center. So this is the middle. And you see how it's starting to layer up right here? 1, 2. And you put the little rotor that goes in the middle, in the center. And it will sync up with the outer rotor because that's the way the magnets are best aligned for this. Most people would say, you know, do left, right. It's more efficient, and it won't. It's like, you know, this is the best way for this. I've tried left, right. And it's north facing out, south facing in. So they're attracting each other and making that rotor sync with the outer one. So you can start it by spinning the outside. Oh, what's up, Chris? Heck yeah. So, in order to get a smooth spin on this, your rotor's got to be synced, or this rotor's going to run away. The rotor in the middle is going to run away. You can see how tough that is to pull. There have to be a lot of force to make it run away. but it gets bumpy if it does. So, and the cool part about it is, you know, you got your one end of the coil being bombarded by the north side, right? And you got the other end of the coil being bombarded by the south. And I think that's actually the way it works. So that's like pure saturation right there. That's the front and the back being hit by what it's supposed to be hit by. It's like awesome. um, Now let me think here. What does it do? Well, it's a pulse motor. It does pretty much what all other pulse motors do, without a doubt. I mean, you don't really need proof to know that that's going on. We're gonna put the hood on here. Oh man, there's a trash compactor out there, and it sounds sick. It sounds like it's dying.
Yeah.
Somebody tried to throw too much away. All right. Trash, garbage truck. All right, so this is the hood. It's got the power on it and the circuitry, and it connects to the coils. So it's going to connect to this part. And there's not a lot of shaft left, so let's hope this all goes well. Let me put this down. I want to bundle these up so I can shove them all through this hole at the same time. All right, I hope I got them all through there. All right. Now the configuration of wires is going to be, this one's going to be hooked up to the transistor, and the series is going to go all the way around with the 20 gauge and 26 gauge. Then the rest of the wires are going to be hooked up to this bridge rectifier right here. And see how, when everything gets hooked up, it'll spin right. Just the coils are spinning now. Yay! All right. It's got to be, I think, well, it's good. It's good. Oh, whoa. You see, this thing gets heavy. This thing gets really heavy, and then you gotta like adjust it because this bottom maglev, it starts touching. See, it'll start touching. So you gotta kind of, and putting in a whole nother one on there, this thing wouldn't even be able to go on a shaft at all. I wish I tried, you know. I might have to snake my WD-40 down there. It might be the bearing, because it's not touching. You know what? Before I hook it all up, I'm gonna, oh, there it is. That's what the problem was. That makes sense. All right. Bundle these up again. Very powerful magnetic pull on that bearing. You know what? It's okay. Okay. I have a feeling it's good now. There it goes. And the problem with the triple one is that, you know, you got to really have all your wires tucked as you're testing it, you know. Awesome. Thanks, Chris. Huh. Is it now touching? Oh, it's not touching. Huh. Nope, I gotta get my WD-40, I think. Something's got to be in there. Almost charged up to 12 volts. Nice. Okay. Let's see. There is some glue on the shaft. I'm gonna get that. I'm gonna see if I can't find another, oh, no, I was right about that. I'm gonna get my WD-40. Just grease these things up real good. Doesn't only do that, but it cleans it too. Hello. See, it's that top part. It makes it so heavy that it just, I don't even know, man, what the problem was. But I know it has to do with that. But let's try it one more time. Now I'm gonna have to put this down. Gotta bundle them up. They won't bundle with one finger for some reason. All right. Nope. Damn. All right. Was it that? Could it be this bearing? Did I put WD-40 on this one? Oh man, what the hell? There we go. Make sure everything's still on here, yeah. Okay. I'll grease this one up. Because I had this thing dismantled for a little while. Right. Like magic. You know, it'd be really gnarly is if I tried to put there we go. One got caught underneath. Nope. Oh. The hell? It's not touching. Something's hitting. I don't even know. Oh, maybe it is hitting. Some glue on there, I guess. A little piece of glue. I'm trying to just adjust it so that maybe. Oh no. I didn't think it would be a problem, but now it's like a problem. Well, I'm glad I didn't see, I gotta deal with these wires a lot. And it gets tiresome, but what am I doing? I guess I'm gonna check the magnets, make sure they're flat. I didn't think I'd have to do that, but yeah, there's a little bit of glue on there. I mean, this is a dumb problem to have. Glue, you know, glue in the way. That was, yeah, that's why it's there, because it was really hard to get off. WYSIWYG, WYSIWYG. All those tools I wish I had. You know? Oh. Let's see here. Well, this might be as good as it gets. There it is. Yay. But it's going to stick to the magnet. So let's see about if it works. Yay. So this magnet isn't very magnetic right now. You know what? Let me see if I can't get some of this off here too. Because that's right where the magnet's going to go. Thanks for hanging out, people. This is how you get stuff done. Nobody really wants to see how you get stuff done, though. They just want to see it finished. But you know, there's lots of really like successful channels where they show you how to get stuff done. And I just remembered I do not have another toroid to use. So this is it. I hope this works. Get the glue off. It should work. Because that's what was hitting, the glue. See it drop just a little bit right there? So we'll put the center rotor in. It'll sync up. The outer rotor, almost 12 volts, 11.8, 11.85. Huh. All right, you guys want to see this one work, or do you want to see me hook up some of the other one that I started out with? Which one did you think was cooler? All right. Because I don't know, man. And like if there's a 1,000 people here, or you know, 2 people here, I'm gonna be treating it the same way. in regards to how enthused I am about what's going on. I think it's great. Kidding me. There we go. Oh, you can hear it now. All right, I think, with adjustment, it'll function properly. But I don't want to like hook all that back up and have it not function, because that would be wrong. I mean, I don't know where all the excess weight came from. It looks good. Here, let me put this up. I mean, it looked good the last time though too, but there was glue on it the last time, so I think it's good. Heck yeah. Ah, that's a dead end, dude. What's up, man? Yeah, actually, the one that I was started out with was salvage from two of them that I did before. I'm really not down to learn. Chilling. That's right. That's what we're doing. Peace be upon us. All right. So that took forever, and that's because the weight pushed down the bottom maglev too much. It looks like it's good right now. Yeah, this is the one that I've been working with for the last month. So yeah, man, the big flywheel, dude, that's legit. I like it. And like I've been saying, this thing will do what any other pulse motor will do. It's just like twice as hard to get the readings from it. You need a commutator for the readings. You need a slip ring for the power if you want to do a power supply. And I guess eventually I'll be able to hook all that stuff up.
There's 1,000 people.
Right, yeah, no kidding. All right, since it's functioning the way I want it to, I guess we could hook it up. Yeah? All right. And I can barely see. Here we go. All right, so front half of the transistor is hooked up. Um, Alright. And I don't talk much when I'm building, so I'll do the best I can. Right now I'm doing the series connections. For the drive. And for the induction section of the whole thing. Wow, man. There we go. That didn't seem like much of a help though, did it? No, actually it was a big help. Thanks, Dead End Channel. I really appreciate it. Wow, that's hard to stay still. Holy shnikes. All right. So we go in that one. Yeah, and see, I don't know why I never said that I was going to do something new every show. I never did.
Yeah, there's more messages
Right on. Right on, man. Come on, get in there. So, there we go. So the drive is hooked up now. I could run it now. I won't get any induction off of it. But I could definitely do that. Let's. All right, so this one is going to go here. The positive side of the, well, the AC, you know what I'm saying, the AC connection that goes on the bridge rectifier where where the notation is, or the positive. I like to call it the positive terminal. Oh man, oh. This is why I have trouble soldering. It's not that I don't do it. It's just that, oh man. Mm. Anyway, I do think the Kong wheel is something I have never seen before, so that's awesome. In my opinion, that's gold right there. Does that get you off grid? Come on. There we go. Take a minute. Man. I think it's because of my medication. But all right, so this one we're gonna go here first. Since the end had broken off. Oh, that's all we got. Oh, this is gonna be got it. Yeah. I love it when I get it on the first try. All right, now I'm not confused. This one goes here. So we got all this extra slack, which I had, and I do have a smaller one. Let me get a smaller jumper wire. Yeah, I can do this without breaking anything. All right. Oh, awesome. Awesome, man. Awesome. All right. So now we just need to connect it to the other AC input. That's this one. Oh, too bad it's not way on the other side. Maybe I didn't think that one through. So I'll need that wire again. Oh no, wait a minute. This isn't long, it's not long enough. All right, that's golden. I just need to get the wires out of the way. Almost shiny again, man. Almost shiny again. I'm putting a lot of elbow grease into this. It got corroded. Very little bit. It's got some copper in it, so it got some tarnish. Some silver, some brass. I'm not sure what it is, but it does tarnish. Probably brass. 1297. All right, here we go. How are we going to do this? I think we're going to use a little bit of Gorilla Tape. After like the 14th time of taking this apart and putting it back together again, having a couple ends break on me, like this part right here, that's as good as it's going to get because it's so small. The end is so short. I won't even be able to get it up here. Yeah, there you go. There you go. Now, if we can get it clear, we can actually let this thing spin for a little bit. Now, I got options here on what I'm going to do. I was thinking about making a dome, like a dome, just to cover it all up. But I don't have a dome on hand, so it's going to be with tape right now. So I'm going to make it as clean as I can. So I saw a little bit of your previous wheel, and I guess I did get a little bit of the back story on how you were, around, and then you weren't around for a little bit. Now you're back in full effect, right? Your story. All right, just a little bit more. Something's not right. Yep, that's not good. It's all right though. It's something's not plugged in right. I'm hoping it's going to be simple and not a contact, you know, like a wire. Then, you know, you don't know where it is really. Did I unplug something? No, I'm gonna have to do this later. That sucks. That sucks. It's all right though. I mean, I'm not upset. Maybe you guys are upset. I'm gonna save this piece of tape just in case I can get it going. Nope, there's a lot of lens here though, with the power on. So there's definitely, I don't know where it's at. Normally I get this right. Oh, I don't know if that's going to make a difference.
It's like, is that it? Is that it?
I'm gonna have to redo all of it just to get that back in there, but I believe I missed a couple connections. All right. Let me make sure. So I think this comes off here like this, and this goes in this hole like this. All right, now yeah, I still don't know why it isn't working. And it wasn't reacting like the transistor was bad, so I don't know. Yeah, it's definitely something's not right. I have no idea what it is though. Could be the transistor. But I'm going to take this down and get current. That was fun.
See. All right, I'll be back.
All right.
Nice work.
Yeah, thank you. This has happened like 1 or 2 times before. Oh. Yeah. Yeah, it happens. Either wires touching or the transistor's blown. You know, something happens. Right. Ooh. Battery's getting charged up now. back to current. For current, I've currently salvaged some older ones that I plan on kind of perfecting. Now on this one, there's two rotors, and the inner rotor has the coils on it. I like this way better. It's a little bit more of a challenge. We got 8 coils on this one. 3 trifilers and 3 bifilers in 180 circuits. We're going to have 3 transistors, 3 batteries, 3 circuits. And then we'll have 2 induction coils for pure induction purposes. Made out of 32 gauge on the sides here. Boom. Yeah, I have a feeling something blew. It's been moved around a lot. But I think this one's going to be more balanced. And since all the circuitry is on 180s, until I build the 8 magnet outer rotor, the 180 magnets is going to have to work. So I'm waiting for a bunch of stuff to come in. I'm going to get more breadboards this size. There's going to be a lot of series connections here, so to minimize all the stuff that we're going to need. This is my favorite one, man. This is like one of the funnest ones with the 8 coils on it. Oh man, it's going to be a blast. So I'm going to put 3 batteries in the center, make a little triangle, and I'm going to build everything off of that triangle. At least I'm going to try. Keep it balanced, you know what I mean? These are the batteries. If you can give me an SLA battery small as this or smaller, I'm in. I will use that and we will make things happen. But I've never found one this small. Looks like we're up to 13 volts now. And then one battery, this one's at 12.66, so I think it's good. I think when this one settles down after I unplug it, it'll be around 12 volts. So the way that I want this one to work is there's 26 gauge in all 6 drive coils, and I want, well, that isn't going to work. But then they have a 28 and a 32. So we're going to make it like this. So it'll be like, I'll have to draw it out. You know, I'm a little unprepared to demonstrate the angles and everything, like, but it's like 3 lines and then 2 lines like this and then 1 down the middle, basically. And then like this, these coils are induction coils. They're 100% 32 gauge, one strand. They're designed to pick up voltage, not amperage, voltage. And then I have the 328 gauge strands that I'm either going to put in, you know, that induction cycle, or I'm going to use them as trifilar strands. You know, they're each going to have their own load. Now, none of these loads are going to be like humongous. I'm not running washing machines. I'm not doing anything like that. No appliances. It's more like light bulbs. I mean, you can look at this right away and you can tell that it's not going to run your washing machine. Maybe it will. I mean, the one motor that you showed us, that was awesome. And when this thing gets going, when it's on, man. Now, I'm going to stop that because I don't want to lose any of my wires. I have already lost one. They're all good right now. I've tested them, made sure all the ends are there, and it should be good. And need to get at least 2 more of these bulbs. You know, I'm just counting down exactly what I'm going to need. All that stuff is coming in the mail though, so I don't really need it. Just have to wait for it. And then this cone stator is wobbly. It's not even. So I'm going to make a new one with 8 magnet holes instead of 6. And it'll sit a lot lower on the pole, so the rotor won't be all the way up here on the top. I think that's important to not have things up at the top of your shaft, unless your shaft is part of your rotor. Then it doesn't really matter. Then there's different rules. But if you're spinning around the shaft, it's important not to be as high as I am right now. Yes, actually, I tried wrapping a coil around one of the magnets. It was on my amp funnel build, and the last, coil in the amp funnel was wrapped around the toroid that was maglev in it. And I'm like, I'm surprised that isn't getting hot. I was like, it was such a short amount of wire wrapped around the magnet. But I am going to have to get going here pretty soon. Maybe in an hour. I gotta go get my son. All right, so let's just get like a blueprint, basically, of what's gonna happen. And I want to get a weight check, since we're all on magnets, like levitating on magnets, it's good to get a weight check. put it upside down for now. Might have to swap my batteries. This one's pretty good. All right, so what we're going to do is we're going to make the trunk, we're going to center it. And we might have to scrape, we're going to scrape the top of this thing off. When we do the final build, man, it's got to be smooth, or I got to print another one. Right there, like that. And then each one of these is going to go in front of it. I'll have more in a day or so. And it's simple, you know. It's gonna the circuit is going to replicate itself around the octagon in a triangle. And I'm hoping that that will keep it the way it is. You know, it's pretty balanced right now, but when you start putting stuff on it, and then for the induction, you know, I was thinking one of these, maybe right over the top. But I mean, like, as soon as I redo this, it's going to change. But, or maybe get a smaller one, get one of the little square ones. It's a bridge rectifier with smoothing caps on it. Yeah, pancake coil. I think I have some wire, speaker wire. I might be able to make a pancake coil. I don't really have any like stencils or anything, and there's no real like. Maybe I could use the paper towel holder in the kitchen to help me wind one. And if you saw me putting this thing together, the previous thing, even this thing, you know that fine motor control is not my favorite. But don't the fields got to be perpendicular to, you know, merit a substantial response instead of, you know, parallel, like putting the pancake coil, the fields are going to be, no, I'm wrong. I'm wrong. I'll see about it. It's just the shapes are the same. It's not the fields. Fields actually penetrate outward and aren't in the same. Just thinking about it. And I got a lot of questions I need to ask, man. It's like, I was just in the middle of asking questions and then everybody ran away. Yeah, right after my buddy told me how to make these, he disappeared. And then I found him on TikTok. He said it was good on TikTok. All right. Man, I want to spin that so bad. But I got to bundle up all the wires again. Well, I'm not going to be able to really build this thing until tomorrow since all the stuff is coming overnight. So I will bundle them up. Now the torque on this thing, after I build the base, should be pretty cool. I should be able to like, attach an extension here and wrap up my extension cords with no problem. But I like doing it in my hand, so that's not really a good purpose or use, but it is nonetheless. It doesn't look like there's going to be enough room. I mean, maybe in the other one there will be enough room. You want to know the coolest coil that I've ever had the pleasure of using is this one right here. It's 20 gauge and 20 gauge. It's got two triggers, one for each 20 gauge. And when the two 20 gauges interact, when they're both on, what is presented is very bright, especially if you have a light on, plugged in. It's brighter than if it would have been plugged into the wall. But just one 20 gauge drive, it's dim. It's dim. You mix them and it gets really bright. And then I had what did I have? Oh, yeah, I have a perfect system. It's like you force charge the super cap bank when it's running your system, and it works. It works. It so works, and that way you mitigate how much energy you're spending from your battery. And if you can mitigate that, you're ahead of the game already. And that's for what I'm doing. Yeah, of course you could go on and you could say yada 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 yada. You ain't got nothing. Yada yada yada. Of course you could say that, but I don't know. I would never accept that as a viable answer or question. I know there's something here. Whether or not I'm going to be able to unlock it, I don't know. But I'm going to keep playing with it. I know that this, the 8 coil rotor is going to be something special when it's done. And I just need to focus, make sure all my components are right. So I do think that there wasn't much of a drag or a pull when the coil, when the magnet went past the coil. So I don't think it was a blown transistor. I think it was a crossed wire. So I gotta clean it up, man. There's no way around it. It's just that I have no like concept in my mind on how exactly to do that. It's solder, yeah, but that doesn't mean anything in my mind. Nothing. I don't know how to do that. I don't know. It's easy. Yeah, okay. It's easy. I don't know how to do it. And I shake so fucking badly that it's like I'm gonna need somebody to do it for me, kind of thing. Awesome. That thing spins so good. Like at least a minute. At least a minute. I think it's been a minute. Like way more than a minute. And the weight, because the coils, man, it's so evenly distributed right now that, I don't even want to put the power on it. Like, and you'd say, there's arguability that no, it's a even-sided shape with even-sided points, and you're not going to have a center hole that's right. I believe, honestly, it's when you flip from imperial to metric and then back to imperial, and then you start fricking with your hole. That's when you screw it up. If you make the hole in metric, you cannot change it after you go back to imperial, or you're going to screw it up. So, I mean, you can go back and forth, but you can't. You get what I'm trying to say? And I found that out a lot. There'll be that extra little tiny part of a square on the top and it won't be on the bottom. That's because I moved it. After I went back from metric to imperial, I moved it. No, don't move it. If you're going to have to eventually move, it should be the last thing that you do. Don't move it. The center hole should always be the last thing that you do. And that's a new rule for me too. It's like, and most of the time it has to be the last thing anyway. But I mean, if you make the hole in metric, so my bearings are 26 millimeters, but everything else is done in inches. So I flip over to the metric system, I make the center hole, and then I send it off. I don't go back to imperial and mess with it after that. And I'm telling you, I don't even know, like the metric lines up perfectly. But when you change it over to imperial, like I said, there's that little tiny part of a square, and it's like, God dang it. So, I mean, honestly, the best way to do it is do your whole thing in metric. If you have metric bearings, do your whole build in metric. Wow, that thing is still spinning. That's so cool. Yeah. But since it was a 4 coil series connection, there could have been a blown transistor for sure. And I wouldn't have even noticed it because it's so, spread out between the coils. Well, I'm going to have a lot of fun putting this together. Yeah, it's going to be quite a bit of work. I mean, there's 8 coils, and 3 of them have 6 ends. 3 of them have, no, the one has 9 ends. 3, there's a lot of ends. Hopefully, I'm going to be able to use some, maybe even terminal block. A terminal block would be really good here. Like one of these kind of, except a 3 clip, 3 on each side, and then I'll be able to consolidate. Very much. See, after the torque from my spin goes away, man, this thing is solid. Really solid. All right. Half an hour, and then I got a boogie. Wow, man, I love this thing, man. I'm so impressed with how smooth it is. And I guess with 26 gauge being the drive, it's not going to be the most powerful spin, but it's going to be awesome. It's going to be smooth. I'm going to be able to let it run without having to stop it. I believe I will. I'm not exactly sure, especially if we're going to have 3 parallel at 180 circuits. All right. Made out of aluminum. Yo, yo. What's up, Chris? Yes, sir. Thank you. You know, if I put aluminum, if I make it right, and I put an aluminum shield on the top and aluminum shield on the bottom, they will counter rotate. They will spin with the rotor, like with the motor, like it is. All right. Well, I'm gonna build something, and we'll see how close it is to what you're talking about. Um, I could add the aluminum shielding, but that, you know, that's gonna come way into the future, because that probably be about as, you know, the diameter of this. See, I don't even have the motor hooked up yet, or any of the circuitry or the batteries. Sounds like you got your work cut out for you, Jerry. I agree, man. That sounds like a blast. Sounds like if you get it right, it'll look really cool. All right. So I need to make more of these. Put them over on my other table, and then I can use this. I love this thing. And this is my axial flux big magnet rotor. Um, you know, arguably the bars are stronger because they have more length, but these are like twice as thick as the bars, and they're pretty long. I mean, they're square, but they're still pretty long. They're like it's like maybe an inch and a half or something, maybe a little less. M52s. They haven't failed me yet. So I was thinking that, well, I'm gonna have to build an 8 slotted spinnable stator. And it's going to have to spin just as well as this one does. It'll be awesome, man. It's going to be great. It's going to be a little bit flatter than this one, more like a saucer shape. Make the bottom flat, like a spot for the magnet, so you get it centered. And then make 8 holes instead of 6. I'm probably gonna have to make it into 9 pieces. Make the centerpiece a big 8-inch disc, and then make the magnets come up, I don't know, 2 inches, and have the slot be big enough to hold them. See, I gotta build it first, the plate, and then put the magnet on it, and then find out exactly how much space is gonna be there so that I can make the right size. See how the magnet is a little bit lower than the coils? Yeah, man, so we're gonna make them level. And I don't want to confuse people as to like what I'm capable of doing. You know, I'm an accountant. You know, that's my degree. That's what I have my degree in, is accounting. I'm not an electrician. I just like having fun with stuff, and I like the fact that this will eventually move without me spinning it. You know, I'll just start it like this, and then it'll go for hours without me touching it. That's awesome. I mean, you need a battery and you need a transistor. Hell yeah, Mike. Without a doubt. How you doing, Mike? Wow, this is so smooth, dude. Oh my goodness. All right, now the torque from it's gone, and it's spinning like good. We're getting a little vibration from the big one because it's uneven. Yeah, yeah. The accountants make a lot of money. I wish I was good enough to like get a good job. Maybe, who knows? I haven't even applied it. You know, I haven't tried at all. I got my degree in 2010. Yeah, you can always stop by and put your input in, my man. Don't. As long as YouTube put up with my BS, man, you can put it in whenever you want. All right. Oh no. Hello, Paige. Hi, Mom. All right, my mom's here. That's awesome. A spring magnet? That's awesome. How does that work? You just magnetize a spring, right? Or so I'm gonna have 6 coils with high induction, electromagnetic induction, and then 2 coils are going to be magnetic induction, and they're all going to be hooked together in series. So we're going to get a sine wave. I mean, if I hook my slip ring up to this one, and I believe we're going to get a sine wave, and then we're going to get our electromagnetic induction wave, which is going to be more spiky. But the 2 coils are going to provide us a sine wave, and I bet you it'll be a pretty good one, even though they're small coils. I'm thinking maybe like 60 or 70 volts. But then the induction coils are going to carry amps. The electromagnetic induction will carry amps, and it will carry a lot more power. For the spin motion of the rotor. No, and that's the funny thing, because I suck at math. Accounting really doesn't have anything to do with math, but I suck at math. I failed algebra 4 times, straight up, and I was like, 12th grade math before that, so I don't know what happened. Something bad happened. I don't know. But accounting is not math based, really. I mean, there's math in it, but the equations are different. Oh man. So there are 3 coils with 3 strands in them. There's 3 coils with 2 strands in them, and there's 2 coils with 1 strand in them. Now, the 6 coils with multiple strands all have 26, so that's going to be our drive. And it's going to be 180s, like a shield symbol, I guess. It would be on the shield. You got your your spears. I don't even know, but you got an X, and then you got a line going through the X. And with that setup, these 2 magnets will work. It will work fine with the 2 magnets. Oh man, I can't wait to see the induction, like electromagnetic induction of this thing. And if I can ever see it, I keep on forgetting that with the counter rotation, you need either a slip ring or a commutator and a slip ring. Like if you have 3 sections, you're going to need a slip ring, because the commutator hooks to the shaft. And in this case, the shaft doesn't spin. So there you go. Right there is a huge problem with the commutator. Now there's the ones you can buy at the store, I should say. Now there are other ways to make commutators. I've made a commutator using 2 plates of copper and 2 brushes. It worked really good. Well, it didn't work really good. It was really inefficient, but it worked. Yeah, tax code based, very much so. Um, oh, I hear you, man. You're trying to get this to be perpetual motion. That's what you're trying to get me to make here. And I know it looks like that, but I don't think this one will ever move like that. Now, what I might try doing before I hook it up with all the power and stuff is use diodes and connect, the coils in series, and then connect them in other way series, because there's multiple strands, so I can go multiple ways. And then the 3 coils actually have another option, so I don't even know what to do with those, but I'll figure it out. I do want to try something with diodes though. And maybe a reed switch. About 15 minutes. Oh, I gotta pick my son up. It's gonna be a blast. The outer field on a field cam that you can change timing with a dial. Oh, like a pot? You mean like a potentiometer dial? And you gotta realize that once these things start spinning, you don't get to change anything. See? That you'll understand. You don't get to touch it after it starts moving. And if you don't have your slip ring and your commutator, then you're not going to be able to move that dial. You can set it before you start it. Yeah, preset the dial. Absolutely. You can set it before you start it. But you are talking about a potentiometer, right? Kind of. Same kind of dial, right? Okay. Yeah, I got a bunch of them somewhere. Got a nice 25-watt one that we could use. But I doubt it will be on this build necessarily. There is like no, when I'm done building the power, I don't know now. We'll see. We'll see what happens. I don't know what I'm gonna do with it now. If we go your way, Jerry, we don't need power, do we? Well, that sounds promising. So I'll look into that. Uh, See, what I'm going to do, my first experiment, is I'm going to hook up all the 32 gauge strands. And I'm going to put it in this side. And then I'm going to have a reed switch hooked to the 26 gauge strands on the other side. I'm going to see how that works. Thank you, Jerry. I think it's really fun, and I'm glad that I know how to build these. It's really a blessing, you know. You're so fun to watch, and then if you put in, you know, extra time and you got extra components, then you can actually, if you run it with power, you can get power out of it, like more power out of it if you can hook it up to retrieve the power. But yeah, I think I'm gonna have to call it for right now, and I'll check everybody later. Uh, Probably later on tonight. We'll see how far I get along with this. Thank you. Yeah. All right, Jerry. Peace. Bye now.